Hey everyone, welcome to this explainer. Okay, today we're tackling a topic that is absolutely fundamentally critical, the future of our water. I mean, we all take it for granted, right? You turn on the tap and boom, it's just there. But behind that simple action is a massively stressed system that frankly desperately needs a paradigm shift. So let's just jump right into it and look at how we transition away from our vulnerable, rusty setup and move toward a really smart, closed-loop paradigm.
To really set the stakes here, let's start with just one single number, 1%. Of all the water covering our entire blue planet, the oceans, the ice caps, the glaciers, literally only 1% is accessible surface freshwater. That tiny, tiny sliver is what we rely on to sustain our entire global population, all of our agriculture, and our industries. When you realize just how razor-thin that margin is, well, the scale of our current mismanagement becomes pretty staggering.
And that brings us to a statistic that honestly kind of blows my mind. 80%. Globally, 80% of our wastewater is just not collected or treated appropriately. Seriously, let that sink in for a second. We're pulling from that precious 1%, using it exactly once, and then basically just dumping it. And here's the kicker. With forecasts showing almost 70% of us are going to be living in urban areas pretty soon, our global water demand is actually expected to exceed our supply capacity by 40% by 2030.
Which leads us to a super crucial question. Can our rusted, linear pipes actually survive the realities of climate change? Look, the vast majority of the water infrastructure we use right now, our dams, our sewer networks, a lot of that was built way back between the 1930s and the 1970s. These aging, linear systems are suddenly facing extreme climate stressors they were literally never designed for, from devastating floods to prolonged brutal droughts. We are essentially relying on a totally outdated mindset to solve a uniquely modern crisis.
So where did we go wrong? Well, the contrast is pretty stark. The Earth operates on this natural, circular water cycle. It's a perfectly balanced, infinite loop of precipitation, infiltration, and evaporation. But us, we went and built a completely artificial, linear water economy. We take from the source, make it drinkable, use it, and discharge it. It's a take, make, discharge model. We force this one-way street onto a resource that is, by its very nature, meant to be circular.
The solution to this crisis is a total shift in how we approach things, grounded in what's known as circular water management. At its core, this boils down to three main things. First, designing our water utilities to actively cut out waste and reduce pollution. Second, keeping the products and materials we derive from water and wastewater constantly in use. And third, fundamentally regenerating our natural basin systems to make sure the supply is there for future generations. It basically means stopping the drain and making every single drop work harder for our communities.
To actually pull this transition off, we need a robust circular economy water framework. Now, obviously, the core principles of reducing and reusing are super important, but the real magic, the crucial enablers wrapping around all of this, are digital technologies and circular business models. We just can't do this with only pipes and concrete tanks anymore. We need smart controls, real-time IoT data-driven models, and brand new economic models that value water not just as some cheap commodity, but as a really dynamic carrier of valuable resources.
If we break this framework down, we get these actionable circular strategies. First off, we reduce usage right at the source. Then we implement tech to remove pollutants. Next, we reuse and recycle water for multiple purposes. Step 4, we actively recover valuable resources, like minerals and energy, straight out of the wastewater. Fifth, we replenish our natural basins. And overarching all of this, we fundamentally rethink the entire water economy. It's essentially a comprehensive roadmap for keeping water constantly flowing in a closed loop.
Zooming out for a second, this is what that closed loop actually looks like in action. We're talking about a systemic approach that links up totally interconnected sectors. It uses hybrid infrastructure, so blending traditional gray pipes and pumps with green, nature-based solutions. It connects rural agriculture, busy urban cities, and big industrial plants. And by using digital water-smart management, we can ensure the right water quality at different levels and route it exactly where it's needed most, which vastly improves our resilience to climate risks.
But to make that big macro vision work, we've got to totally rethink things on the micro level. Specifically, our wastewater treatment plants absolutely have to become resource factories. Because right now, standard wastewater plants are massive energy sinks. They astonishingly consume between 1 and 3% of total global energy output. If we're going to adapt to climate realities, these places can't just be disposal sites anymore. They urgently need to evolve into active water refineries and energy generators.
To understand why this evolution is so incredibly urgent, just look at how we typically treat wastewater today using aerobic digestion. Get this, over 50% of a standard plant's entire energy consumption happens right in the aeration tank. Why? Well, because the bacteria breaking down the organic waste need a massive, constant supply of oxygen. Pumping all that air into the water continuously takes a staggering, completely unsustainable amount of electricity. And this is exactly where the innovation steps in. Compare that old aerobic method with a truly fascinating process called anaerobic digestion. Now, anaerobic processes happen completely without air or oxygen. So right off the bat, the energy demand is significantly lower because you eliminate those giant aeration pumps. But here's the real game changer. Those anaerobic microorganisms actually convert the organic pollutants directly into biogas, mostly methane and carbon dioxide.
One incredibly effective technology driving this is the Upflow Anaerobic Sludge Blanket, or USSB reactor for short. Basically, raw sewage flows upwards through a suspended sludge bed. The process cleans the water while simultaneously capturing all that rising biogas right at the top. Suddenly, your wastewater plant isn't an energy drain at all. It's capturing alternative energy for heating and electricity. We are literally turning human waste into sustainable power. How amazing is that?
Of course, producing energy is only half the battle, right? We also have to reclaim the water itself, and modern membrane filtration technologies offer some incredible precision here. We're talking everything from microfiltration and ultrafiltration all the way down to nanofiltration and reverse osmosis. These membranes act like microscopic gatekeepers. By applying different pressures, we can filter out everything from bacterial cells and viruses right down to dissolved aqueous salts, reclaiming water to whatever specific quality standard a community or industry might need.
Now, besides clean water and energy, there are actually hidden treasures hiding in our wastewater. Historically, discharging excess nitrogen and phosphorus into the environment caused these toxic, destructive algae blooms, a really nasty process called eutrophication. But today, we can actively mine the water to recover those exact nutrients and use them as highly valuable agricultural fertilizers. We can even recover critical raw materials for industry. So wastewater is no longer a liability. It's a rich, completely untapped mine.
So how do we actually scale these amazing resource factories? Well, a huge piece of the puzzle is moving toward decentralized networks. Because instead of piping all this waste over massive distances to one giant central plant, which, by the way, is incredibly expensive to build and maintain, we can treat the water closer to the source. Decentralized sanitation can complement our centralized systems to form this hybrid network. It makes it so much more viable to reclaim water locally for agriculture or industry without facing immense infrastructure replacement costs. To manage a complex, decentralized network like that, we rely on the Water Content Value Map. By using IoT sensors, digital twins, and machine learning, we can optimize all these circular strategies across the macro, meso, and micro levels in real time. It's this digital layer, essentially, that allows us to reliably extract the physical resources, the liquid fertilizers, the methane gas, the reclaimed water, and actually turn them into viable, working business models.
What we are witnessing here is a profound paradigm shift. The old goal of our rusty 20th century linear system, it was just about discarding waste safely, but the urgent, fast-paced mandate for the 21st century is mining water. We absolutely must aggressively build these interconnected, smart, green systems that guarantee real climate resilience. We are moving from a fragile, linear pipe to a dynamic, closed-loop engine.
The mandate here is crystal clear. The water sector must urgently scale these technologies. By linking up digital integration, membrane filtration, and biological extraction, we can harvest water, energy, and nutrients across entirely interconnected sectors. Look, this isn't just about saving a few drops. It's about providing zero-carbon water services that actively adapt to the harsh realities of climate change. So, knowing that only 1% of our surface water is accessible, and knowing we possess the technology to extract immense value from every single drop, what are we going to do? Will we continue to let our future just run down the drain, or will we step up, demand a regenerative, zero-carbon future, and actually close the loop? Keep learning and keep asking the right questions.